Go and open your book to page 727. Today's lesson is to find a number of ways in which combination of elements can be formed. So before this, we learned about permutations, right? So today we're going to learn about combinations. So the difference between the two is that whenever you have to arrange things in order, so when you see the word arrange or order, that is permutation. Whenever you want to get a group of things, a committee or team, you're just going to grab something, the order does not matter. Okay? If it doesn't matter which one comes first, then it's combination. So let's go to example 1. So you have the 3-letter subset. 3-letter set. Okay? So remember, a set is a group of things, right? So this one have a set of 3 items. A subset is what can you make from that. Okay, so A, you want to specify. Specify means list them. Okay, so it says specify means list all the subsets. Subsets means the sets you can make out of these. Again, the sets, the order does not matter. So you can start with the one with nothing, right? So you start with one with nothing. So this is called an empty set. You can start with the one with only one item. You make sure you do it in order so that way you don't lose track. So you start with not element, then you start with one element, then you do the 2. So E, F, right? So you left out the G, right? So go and leave this one out, and then leave this one out, right? Just go in order, right? And then you leave this one out. So you start with 0, 1, 2, and then do the 3. And so that would be all the subsets. Okay, now you go to B. You want to specify 2-letter subsets. 2-letter subsets are these 3 over here. So it would be EF. Again, the sets, the order does not matter. It's just the content. Okay, and so that's it. Now notice over here there are a total of 8 subsets, right? Okay, these are called proper subsets. This is called improper subset. Okay, so just some of the terms. And total number of subsets are possible would be 8. Okay, now the formula to find out the total number of subsets is 2 to the n. Okay, n is number of elements. Because the reason is 2 to the n because think about, right? When you're making subsets, you have to decide to use or not to use, right? So there are 2 choices, to use or not to use. This one, to use the F or not to use the F. So that's 2 choices. To use the G or not use the G, there are 2 choices. And that's why it's 8, right? So that's how you figure out total number of subsets possible. So make sure those on the math team, you got to know this, okay? Especially if you're going to do the combination, permutation, or probabilities. Okay, so again, 2 to the n. Okay. Now, next, let's go to example 2 on page 728. It says find the number of combinations of the letter A, B, C, D, E, taking them 5 at a time. Okay, now, the formula to do this, so C is combination. And the first one, the 5, is the total number of elements that are available. And the second one is how many you are using. Okay, now the way to evaluate these is the formula on page 729. Okay, so NCR is equal to n factorial over r factorial n minus r factorial. Okay. So in this case, this is going to equal to 5 factorial, right? The total goes on the top. Okay, then the r over here, so it's 5 factorial. So this number goes on top, this number goes on the bottom, and the difference. So difference, it would be 0 factorial. Okay, now 0 factorial is equal to 1. So 0 factorial is equal to 1. 1 factorial is equal to 1. And 2 factorial is equal to 2 times 1 equal to 2. And so forth and so forth. Okay? So you got to know these two over here. So this is equal to 1. And 5 factorial over 5 factorial is equal to 1. So answer is equal to 1. That's only one way, because there are 5 items and you're going to get all 5 of them. So how many combinations can you have? Well, answer is 1, right? Just like this over here. See, you got 3 and you're going to take all 3, so you only have 1, right? Right, that's only one way. Okay. Now let's go to B. So B, you're going to take 2 at a time. So like this one over here, right? Like this one, if you have 3 and you're going to only take 2 at a time, so you have to figure out how many are possible. So this is, so there are 5 items and you're only taking 2, so it's 5C2. And so this would be equal to 5 factorial over 2 factorial, and the difference would be 3 factorial. Okay. Now the easy way the easy way to evaluate combination is it's very simple. You see this 2 over here, just put a 2 factorial over here, 2, 1. Okay. Notice that 3 factorial will cancel out. So this is equal to 5, 4, 3, 2, 1. This is 2, 1, 3, 2, 1. Notice this will cancel out with that, so that's, you're going to end up with that. So instead of doing this all the time, the easy way to do this is this. See the 2 factorial, you just put down here. Now if there are 2 numbers over here, you're going to get 2 numbers on top, because the other one will all cancel out. So you can see the 2 over here, put 2 factorial, and then if there are 2 numbers down here, you're going to get 2 numbers up here. Everything else will get canceled out. So that's how you do it. And you just go and cancel, and so answer equal to 10. So you can do this very quick a lot of times, without how to use calculator. Okay, let's go to example 3. Okay, it says, in how many ways can a committee, so that's your clue, right? When you're getting a committee or group or team, when the order does not matter, right away, that's the combination. So over here, example 3, how many ways can a committee of 6 be chosen from 5 teachers, so there are 5 teachers and 4 students, if all are equally eligible. So if all are equally eligible, so there are a total of 9 people, right? There are a total of 9 people, and you want to choose 6. Okay? Now, because of the factorial, because of these, right? Okay, what happens is that this will equal to the difference. So this is same as 9C3. Okay? Because so choosing 6 is same as not choosing 3. Okay? So you can see that the difference, 9 minus 6 will give you 3. This would be easier to evaluate because this is equal to 3, 2, 1, be 9, 8, 7. And you can just go and cancel, okay? And then, so this will equal to 12 times 7 will give you 84. Okay? Now let's go to B. The committee must include 3 students and 3 teachers. Okay? So you want to get 3 students and 3 teachers. So now there's restriction, right? So there are 5 teachers, but you're only going to get 3. So for the teacher, it's 5C3. Okay, for the students, it's going to be 4C3. Okay, so you need to get 3 teachers and, so it's multiplying, right? 3 teachers and 3 students. And this is same as 5C2, and this is same as 4C1, right? The difference. Okay. Now you don't have to do this because you can just enter on your calculator. But since I'm doing manually without calculator, so I'm doing it this way. So it'd be 2, 1, 5, 4, and this would be just 1, 4, right? So you cancel, so it's 40. Okay. So there are 40 ways. Okay, let's go to example 4. it says a standard bridge deck of cards consists of 4 suits. Okay, so diamonds, clubs, hearts, and spades, of 13 cards each. This is just in case, for those who not familiar with cards. Okay, it says how many 5 cards hand can be dealt, including 4 cards. So there are 5 cards total. Okay, so 5 cards. You want to get 5 cards total. It must be including 4 cards from the same suit and 1 from different suit. Okay, and 4 same suit. Okay, so first I need to do is there are 4 suits. Okay, and 1 other. So first I'm going to choose the suit. So there are 4 suits, right? I'm going to choose that 1 suit. So once I choose that suit, right? Within that suit, there are 13 cards in that suit, and I'm going to choose 4. Okay, again, so there are 4 suits. I'm choosing 1 of the suit. Then after that suit had 13 cards, and I'm going to choose 4 from that same 4 cards from that suit, right? To fulfill this condition. Then I have to worry about the other. Okay, now there are 39 other cards, and I'm going to choose 1, right? Because this suit had 13 cards, so there are three other suits left. So from that 3 other suits, there are 39 cards available, and I'm going to choose 1. So you kind of have to follow through the story. Okay, so you get your calculator. So you can just use this button over here. Now you can use the NCR, right? So some of your calculators have these buttons, right? So you can just do that. So 4, now 4C1 is 4, right? Times 13 NCR 4 times 39. Now 39 C1 is 39, right? Okay, and so I get this. So this is equal to 11540. Well, 11540. Okay. So make sure you kind of just have to follow along the story. Okay. Make sure you make sure all the cards are accounted for. So make sure there are 5 cards total, right? So there are 4 of the same suit, and there are 1 other. So there are total 5, right? So again, all the numbers have to match. Okay. And notice over here, see that? 13 cards, 39 cards, so there are total 52 cards. And you're getting 4 from here, 1 from here, so you get 5 cards, right? So everything has to match. Okay. Okay, so let's go and do some practice.